So we're going to have a highlight of all the gastrointestinal regulatory substances and the gastrointestinal secretory substances. Just what is important for the step 1. So first we'll go for the secretory substances. So there are 4 substances which are secreted in the stomach, especially in the stomach. One is intrinsic factor. Number 1 is intrinsic factor, and then you have gastric acid, pepsin, and finally mucin. These are the only things which are secreted in the stomach, and these two, intrinsic factor and gastric acid, they are from the parietal cells. This is from the chief cells. These are in the stomach. Coming to mucin, it is everywhere, in the stomach, duodenum, jejunum, everywhere. So this is stimulated by pancreatic enzymes. So coming to the action, what does the intrinsic factor do? It'll help in, what does the intrinsic factor do? It'll help in absorbing vitamin B12. So whenever there is gastrectomy or something, there's vitamin B12 deficiency, or whenever parietal cells are destroyed because of the autoimmune, the intrinsic factor is deficient, vitamin B12 is deficient. So coming to the most important part is the gastric acid. So how is the gastric acid produced? It needs some stimulation, right? The ones which stimulate gastric acid production are gastrin, which is main, and then you have vagal stimulation, vagal nerve, and then finally histamine. These coming to which subsides, like which inhibits the gastric acid secretion, are somatostatin and secretin. Okay, somatostatin, secretin. Along with this, prostaglandin. Okay, prostaglandin. And also gastrointestinal peptide. We'll talk about these later. So how is gastric acid stimulated? By gastrin, right? So why is gastrin doing this? It needs some stimulation. So how does this get stimulated? Whenever there is increased acid, like when you decreased acid, that means when you eat food, like you eat food, what happens? Stomach is distended, stomach distension. So the stomach distension will produce gastrin. Gastrin causes gastric acid secretion. And another one is when there is decreased acid, that is alkalinization of the stomach content, also causes gastric secretion. Also certain foods like amino acids, peptides, all these also causes gastric secretion. Along with all this, vagal nerve also causes gastrin. So this vagal nerve stimulates gastrin, which is produced by the G cells. Gastrin, G cells. Okay, this G cells produce gastric acid here. Okay, this gastrin is produced in the G cells into blood, and this gastrin in the blood goes to the stomach and produces stimulates parietal cells, and this parietal cells produce gastric acid. Coming to the another stimulation is histamine. So what happens is, when this gastrin is stimulated, it directly stimulates the parietal cells. Also, it produces histamine in the blood. This histamine travels to the parietal cells, also stimulates gastrin and produces gastric acid secretion. This is how this happens. So whenever there is stomach distension, when there is less acid, that is alkaline pH in the stomach, amino acid, peptides, everything causes this. Also, gastric releasing peptide stimulates gastric release. So coming to the clinical aspect, so what causes increase in this gastrin production? So proton pump inhibitors. So when you take proton pump inhibitors, these proton pump inhibitors act on H plus and potassium, whatever that particular pump, and there will not be production of H plus. This production is gone, so there will be less H plus, right? So that will cause alkaline environment in the stomach, which stimulates gastrin production and which stimulates gastric acid production from the parietal cells. Also, another way this gastrin is excessively produced is the Zollinger-Ellison syndrome. Zollinger-Ellison syndrome is gastrinoma. So this gastrinoma is a benign tumor which produces excess gastrin. So there's excess HCl. It doesn't need any. So this is about gastrin. So this is about positive thing. Coming to what causes inhibition of the gastric acid, it is somatostatin, secretin, prostaglandin, and GIP, right? So let's talk about these two later. Let's talk about these two first. So what is somatostatin? Somatostatin is produced in the GI mucosa and pancreatic cells. So this is in the GI and pancreatic cells. So what are the cells which produce somatostatin? D is the word you need to remember. D cells in the GI and pancreatic cells produce somatostatin. So what does this somatostatin do? What it does is decreases gastric secretion, decreases pancreatic secretions, and also decreases gallbladder contraction, and also decreases insulin and glucagon release. So what is the somatostatin doing? It is reducing the gastric secretion, pancreatic secretion, gallbladder contraction. So it's just coming to the gastric secretions, it's doing exactly opposite to the gastrin. So why is this doing this? What is the stimulus that is making this somatostatin do this? Just increase in acid. Whenever there is increased acid, you will have a feedback to somatostatin is released. There's increase in acid, somatostatin is released, and it causes this. Coming to another one is decreased vagal stimulation. Decreased vagal stimulation also causes somatostatin to release D cells to release somatostatin, which causes decreased gastric cells and parietal cells. Coming to the secretin, it's almost like somatostatin, but it's a bit different. So which cells are producing secretin? Secretin S cells. So where are these present? Definitely in the GI, because it's acting on the GI. So that is in the duodenum. So the GI system, where duodenum. So what is it doing in the duodenum? Of course, it has to reduce the gastric acid secretion. So one is decreases gastric secretions. So the other thing which it does is increases bicarbonate, increases pancreatic bicarb secretion, and increases bile secretion. So what is it doing? Along with decreasing the gastric secretions in the duodenum, it is increasing the pancreatic. So what is it doing? It's kind of diluting it. So definitely the stimulus for the secretin has to be high acid. Imagine a high acid content of the gut, the gas of the stomach coming into the pancreas, into the duodenum, sorry, into the duodenum, and you don't want that much of acidity in the duodenum, acid content in the duodenum. So what happens is the secretin is released from the S cells of the duodenum, which causes decreased gastric secretion and increases pancreatic bicarb, which dilutes the acid secretions. So what is which causes this? Obviously increased fat, increased acids and fatty acids in the lumen. And like I told, this is the function is dilution. So coming to the glucose, this is over, right? We have prostaglandins and gastrointestinal peptides, another inhibiting substances of the gastric acid. So let's talk about GIP later. And we know prostaglandins, they do the same thing. That is why what is that? NSAIDs, when you give, you have increased gastric acid secretion because they inhibit prostaglandins. So this is about gastric acid secretion. Okay, let's talk about this part later. Let's go to the pepsin. So what is pepsin? Where is pepsin being produced? In the chief cells of the stomach. So what does pepsin do? What it does is it digests protein. Okay, so it digests protein. So the stimulus has to be protein, right? When you take protein, pepsin is released. And so what does it do? It is produced as pepsinogen, and it is converted into pepsin when there is excess acid, and it digests protein. Mucin is it is like a neutralizing acid. It is produced everywhere, and it is increased by the pancreatic and biliary secretions. So that is the case. So while doing the secretory hormones, we actually spoke about 2 regulatory hormones, right? That is gastrin and somatostatin. So let me write down the regulatory hormones here. The regulatory hormones of the GIT are the mnemonic is G disc. So G D I S K. G is gastrin, D is somatostatin, I is cholecystokinin, S is secretin, K is gastrointestinal peptide.